Okay, so you're interested in AI winning the 2024 Physics Nobel Prize.
Yeah.
I have to admit, when I first saw this, I thought someone had their wires crossed.
Right.
AI winning a Physics S Nobel?
Yeah.
What's the connection? Luckily, we've got our expert here to help us unpack this.
Yeah, it's certainly an intriguing pairing. And you're right to wonder about the connection.
Right.
The article you sent, What's Up with AI
Right.
and the 2024 Physics Nobel Prize
Mm.
from FinShots,
Right.
does a great job of explaining why this is such a big deal.
Okay.
It's about so much more than just the award itself.
Right. It feels like there's a much bigger story here.
Exactly.
So let's start with the winners.
Okay.
The article mentions John Hopfield and Jeffrey Hinton.
Yeah.
I'm familiar with AI, but not so much with their work specifically.
Well, Hopfield and Hinton are pioneers in the field of artificial neural networks,
Okay.
which form the bedrock of many AI applications we see today.
Right.
What's fascinating is that their journey wasn't just about computer science. It was deeply intertwined with the world of physics.
Okay, so that's the link.
Yeah.
But why physics? It seems like we usually associate AI with algorithms and data,
Right.
not so much with the laws of the universe.
It's all about how these neural networks actually work.
Oh, okay.
Think of the human brain,
Okay.
a complex network of neurons that communicate with each other.
Right.
Each neuron processes information and passes it on.
Okay.
And through this process, we learn.
Right.
We recognize patterns,
Yeah.
make decisions.
Right.
Artificial neural networks, in a way, try to mimic this structure.
So it's like we're trying to recreate the learning process of the human brain,
Exactly.
but in a computer system.
That's the basic idea.
Okay.
Now, this idea of artificial neurons isn't brand new.
Right.
It actually dates back to the 1940s.
Oh, wow. Okay.
However, back then, the technology and understanding needed to really make it work were limited.
Right.
That's where Hopfield and Hinton come in.
So they figured out how to make these artificial neural networks actually work effectively.
Yes.
What were their breakthroughs?
Exactly. Let's start with John Hopfield.
Okay.
In the 1980s, he developed a type of neural network aptly named the Hopfield network
Okay.
that was groundbreaking for its ability to recognize patterns even with incomplete information.
Oh, wow.
Imagine trying to identify a picture of a cat,
Okay.
but the image is blurry or parts of it are missing.
Okay.
Hopfield's network, using principles of physics,
Oh,
particularly energy states,
right.
could still figure out that it was a cat.
That's amazing.
Yeah,
So even with limited data, the network could fill in the gaps.
exactly.
It makes me think about how our brains can often recognize a familiar face, even if we only catch a glimpse.
Right.
But you said he used physics.
Okay.
How does physics play into this?
That's a great question, and it's key to understanding this whole Nobel Prize connection.
Okay.
Hopfield's work drew heavily on biophysics,
Okay.
which uses mathematical models to understand how biological systems like our brains actually function. He realized that the principles governing energy states in physical systems could be applied to these networks of artificial neurons.
So he was essentially borrowing concepts from physics to solve problems in computer science.
Exactly.
That's fascinating.
Yeah.
But where does Jeffrey Hinton fit into all of this?
So Hinton,
Okay.
he took the idea of neural networks even further.
Yeah.
He realized that to truly mimic the power of the human brain,
Right.
AI needed to go beyond just recognizing patterns.
Right.
It needed to analyze information on a deeper level and make predictions.
Okay.
His major breakthrough came with the development of what are called Boltzmann machines,
Oh.
a new kind of neural network that included hidden layers of nodes.
Hidden layers. What do
Yeah.
those do?
So imagine this Hopfield's network could look at that blurry picture and tell you it's a cat.
Right.
Hinton's network, with its hidden layers, could recognize the cat. A&D predict that it's about to pounce on a toy mouse just outside the frame.
Wow. Okay. Now that you put it that way, that is a huge GE leap forward.
Yeah.
It's like the network gained a deeper understanding of the situation.
Exactly.
Not just recognizing what's there, but predicting what might happen next.
Exactly.
Wow.
These hidden layers allow the network to analyze data on multiple levels, just like our brains do.
Right.
And this concept became fundamental to the development of modern AI,
Okay.
paving the way for things like Siri understanding your questions or self-driving cars navigating traffic.
Right.
And it's all built on those foundational ideas from physics.
So we've got biophysics helping us understand how to model the brain's function.
Yeah.
What are the other physics principles that come into play with neural networks?
So the second principle is statistical physics.
Okay.
This branch of physics deals with understanding systems with a huge number of interacting components.
Right.
Think about molecules in a gas or nodes in a neural network.
Okay.
Statistical physics helps us understand how these complex systems behave as a whole,
Right.
and crucially, how to extract meaningful patterns from massive amounts of data.
Okay, so it's not just about looking at individual neurons or nodes,
Yeah.
but how they all work together to create something bigger.
Exactly.
It's like those amazing patterns you see in a flock of birds, how they move together as one,
Right.
even though each bird is making its own individual decisions.
A perfect analogy.
Yeah.
And finally, we have computational physics.
Okay.
This is all about using computers to solve complex physics problems
Mm.
that would be incredibly difficult, if not impossible, to solve using traditional pen and paper math.
Right.
Computational physics is essential for actually building and training the sophisticated AI models we use today.
So to recap, we've got biophysics inspiring the structure of neural networks.
Right.
Statistical physics helping us make sense of the vast amounts of data they process.
Yeah.
And computational physics giving us the tools to actually build and train these powerful AI systems.
Exactly.
It's like physics provides the foundation upon which all of modern AI is built.
Precisely. And the story of this Nobel Prize highlights just how interconnected these seemingly different fields really are.
It makes you realize that groundbreaking discoveries don't always happen in isolation.
Right.
Sometimes it's about recognizing how principles from one field can be applied in unexpected ways to push the boundaries of another.
Exactly. And the impact of Hopfield's and Hinton's work extends far beyond just winning awards.
Okay.
It's transforming how we live and work in profound ways. For instance, take AlphaFold,
Okay.
an AI system developed by Google's DeepMind.
I've heard of AlphaFold.
Yeah,
It's making waves in the medical field, right?
absolutely. AlphaFold is a fantastic example of the real-world impact of this research.
Okay.
It can predict the 3D structure of proteins with incredible accuracy.
Okay.
To understand why this is so important, you have to realize that proteins are the workhorses of our bodies.
Right.
They carry out countless functions, and their shapes are crucial to how they work.
So knowing the precise shape of a protein can help us understand how to design drugs that interact with it effectively.
Exactly. For decades, figuring out the 3D structure of just one protein could take years of painstaking lab work.
Wow.
AlphaFold can now do it in hours or even minutes.
Wow.
It's like having a superpowered microscope that can see at the molecular level.
That is revolutionary talk about accelerating scientific discovery.
Yeah,
This technology, stemming from their work, could potentially lead to the development of new drugs and treatments for diseases at an unprecedented pace.
it's incredible to think about, isn't it?
Yeah.
And that's just one example. We see the impact of their work in so many areas, from medical imaging systems that can detect diseases earlier to the voice assistants we use every day.
It really highlights the vast potential of AI to solve some of humanity's biggest challenges.
Yeah.
But this isn't just about medicine or even technology, is it?
Right.
The article mentioned AI being used in a wide range of fields.
Absolutely. Astronomy, particle physics, climate science.
Mm.
AI is being used to analyze massive data sets, uncover hidden patterns, and make predictions in all these fields and more. It's like giving scientists a brand new tool to understand the universe around us.
It really feels like AI is becoming this universal tool for understanding complexity,
Yeah.
whether it's the human body or the vastness of space or even the intricacies of our climate.
Exactly.
But all this potential must come with some economic considerations, right?
Absolutely. And the article you sent doesn't shy away from that.
Right.
On one hand, the McKinsey Global Institute estimates that generative AI alone,
Okay.
just one aspect of this rapidly evolving field,
Right.
could add trillions to the global economy annually.
Trillions.
Yeah.
That's mind-boggling.
It's a lot.
But I imagine there's another side to this coin.
Yeah.
What about the concerns about AI impacting jobs?
Right, that's the
Yeah.
flip side of this rapid technological advancement, and
Oh.
it's something we need to address proactively.
Right.
The IMF estimates that nearly 40% of global jobs could be impacted.
40%.
Now, impacted doesn't necessarily mean eliminated. It means jobs will transform,
Okay.
new skills will be needed,
Right.
and adaptability will be key.
So it's less about robots taking over
Right?
and more about humans and AI figuring out how to work together effectively?
Precisely, imagine AI handling repetitive tasks,
Right.
freeing up humans to focus on creativity,
Okay.
problem solving, and areas where human ingenuity excels.
Right.
It's about adapting and evolving alongside AI constantly learning and reskilling to thrive in this changing landscape.
It's both exciting and a little daunting, isn't it?
It is.
This massive wave of change, all sparked by research into the very nature of intelligence itself.
Yeah, it really underscores how interconnected our world is. Who
Right.
could have predicted that exploring the physics of the human brain would lead to innovations with such a profound impact
Right.
on our technology, our economy, and even the future of work itself?
It's a good reminder to stay curious,
Yes.
even about things that might seem completely unrelated at first glance. What might seem like a niche discovery today could unlock incredible breakthroughs in the future.
Speaking of connections, the article did mention a counter-argument that I think is worth acknowledging.
Right.
Some people believe that while Hopfield and Hinton's work is undeniably groundbreaking,
Right.
it might be more accurately categorized under mathematics or computer science than physics.
It's true that the lines between scientific disciplines can get blurry sometimes.
Yeah,
Perhaps instead of trying to rigidly categorize it, we should just appreciate the fact that their work transcends traditional boundaries.
exactly. It's in those spaces between fields where innovation often thrives.
So where does this leave us? And more importantly, where does it leave our listener?
Right.
What's the takeaway from this deep dive into AI and the Physics Nobel Prize?
For me, it's about recognizing that we live in a world brimming with possibilities.
Okay.
It's about embracing curiosity, challenging assumptions, and always being open to unexpected connections.
Right.
Who knows what groundbreaking discoveries are just around the corner waiting for someone to connect the dots?
Beautifully said. It's a future ripe with potential, and we can't wait to see what unfolds.
Yeah.
Thanks for joining us on this deep dive into the fascinating intersection of AI and the Physics Nobel Prize.
Thank you.
Until next time, keep those minds curious.